Hi guys, glad to see everyone. Shall we start already? Do you see my screen? I assume yes. Cool. So we'd like to talk about the Sift today. Why do we need it? And what are the benefits of using it? Some of our guests are already familiar with this technology. We improved the framework itself, though. However, some of our guests are, I don't think you are familiar, so it will be beneficial to talk from scratch. So the goal today is to achieve optimal test speed without losing the quality of the test runs. Obviously, that's a high-level goal for every iOS and not only iOS asset. Sift is available not for iOS only, by the way, but today we'll focus our presentation on iOS and macOS, obviously. Maybe later we'll talk about the other platforms as well, since we have Android, since we have Windows drafts already. So we'll talk about this later. In case you don't know who are we are Engenious. We are a consulting and educational company. As of today, we have more than 50 people around 8 countries. We do a lot of different domains and industries, but we're focusing on mobile development. Though a lot of big companies hire us to do the consulting in and helping them with different automation tricks. Obviously, Sift is one of the most powerful tools we have to offer those big companies, such as Apple, such as Grammarly, such as Tinder, etc., etc. So why do they hire us, and what unique skills our engineers do have in order to be productive and in order to achieve this speed of test without losing quality. So first of all, like Sift helps to run tests in a speed, right? So why can't we just parallel the test with a native Xcode solution, right? Because a couple of years ago, Apple officially presented this ability of Xcode to run tests in parallel, and a lot of people thought finally we can increase our speed using just a native solution. However, it has a lot of drawbacks. First of all, you cannot run tests on the real device in parallel, so simulators only. And a lot of apps, as of today, like we want to run them on devices. Depends on like there are a lot of reasons why do we want to run tests on the real device, but obviously it's just more quality control, right? Because we've seen the situation when the app behaves differently on devices and simulators, and the eventual goal is to ship the application to the real user, and obviously they're using devices, not simulators, right? So you want to make sure tests, at least some tests, some crucial tests, run on devices. Xcode parallelization is flaky, so we tested out different case scenarios, and we were able to notice that we've seen some failures without reason, so it's just flaky, right? And it's limited, it's black box, so we cannot really control and set up things there. It's impossible to fix this flakiness because it's black box. You cannot shard things across different Macs, right? So you can run in parallel across the simulators, but you cannot execute tests across different Mac instances, which gives you a pretty straightforward limit of around 4 or 5 simulators for a powerful Mac, for a really powerful machine. Because if you if you tried to run more than 5 simulators on one Mac, it just freezes up, right? It doesn't handle more than 5. Maybe for some very powerful machine, it will be 6 simulators. And obviously, that's not a lot, right? Because if you have hundreds of tests, you want to add more. And the only ability to do this, not by adding more simulators, because like the Mac is not that powerful, but to add another Mac with another 5 simulators. That's a key feature of parallelization. And as I mentioned, it's a black box. You cannot really set up things. You cannot really set up some configurations. How do you want to shard the tests? Do you want to shard them by some particular device properties or by some test suits? You do not have this control. So Sift is an open source framework. It's available via this link or QR code. And it allows to do all those things that I mentioned as a drawback for Xcode. So you can run and shard tests with different macOS nodes. And moreover, you can use real devices if you want, not only simulators. How it works. Basically, the framework itself, so it's very configurable. There are 2 main ways to configure the solution. First one is big configuration file, JSON file, that is available open source. You just feel free to amend different properties in that JSON, and the Sift will behave differently. Please mute yourself. Right, so the second way is using our web application orchestrator, which we are not focusing today on. We'll have a separate webinar when we will tell you about the benefits and pros of orchestrator, but that's just a web-based app that allows to config these Sift things in a nice UI as a web application. But as for now, you can do the same thing by configuring the JSON file. So you can use it for UI test and for unit test. Doesn't really matter for Sift what to run. And how it works. You specify any amount of nodes. Each node is just a Mac Mini instance, right? Or any Mac instance. When you start running tests, then Sift connects through a SSH to all those nodes, clones itself to each of those, and then in this configuration file, you specify the IDs of simulator or real devices that you want to run tests on. So every single node, which is Mac Mini or something, will shard its chunk of tests across its own simulators or devices. As a result, you can see that you can add any number of nodes, and each node can handle up to 5, 6, depends on the power, devices or simulators. So this is a scalable solution. You can eventually shard as many tests as you want. Moreover, once you successfully executed all the tests, Sift will aggregate all the results from all the nodes, from all the Mac Minis, and aggregate it to the only one result in different formats. Moreover, Sift allows you to, if something fails on any of the node, Sift will rerun the test, and the rerun configuration can also be specified in that config file. So that's a solution for us. It's using native Swift 5, Xcode build, and SPM. It's open source. Feel free to check it out. So it's completely native solution. And that's a real case. We had this case in like for one of our clients. They asked us to help with their test runs since they had around 200 tests, and it took 2 hours for them to run this. Obviously, the tests were not very useful for them because nobody wanted to wait 2 hours, right? So basically, they run it only once at night. Once per day, not very productive. And when we integrated Sift for them, we only added 2 Mac Minis and 5 simulators per each Mac Mini. We were able to reduce the 2 hours run to 18 minutes run, sometimes even less. So, they started to use tests much more often, right? Because now it takes only 15 minutes. Why not to run like after every pull request is merged, for example, post-merge, right? Moreover, what's really important, whenever they will add 200 more tests, we'll still be able to keep the runtime within 20 minutes boundary because we'll just able to add more Mac Minis. And then if they add 1,000 of tests, we'll just add more and more Mac Minis. That's what scale is, right? You are not limited. And now I would like to present some demo. Anton, feel free. Let me run it.
Hey guys. Here we will show you the short pre-recorded demo how Sift works. And here you can see we open PR on GitHub, and it will automatically trigger the job on a Jenkins through the webhook. Here you can see the job start running. The job already configured to use Sift. And now we will see that we have all checks updating on a GitHub automatically. And then we can go to the console output and we'll see how Sift works. Here you can see that Sift is running. Boris, can you select the Sift run ---- config? Just show that lane. Okay. Just want to show how Sift is run and provide the config file, JSON config file. You can see it in the output. And on the left side, you can see the test running on the different nodes, nodes 1, node 3, node 4. There is dedicated nodes which located in a different country. In our case, it's AWS instance. And on the right side, you can visually see through the VNC desktop of those nodes and how test is running. And when it finished, we got the final result file, which aggregate all results from all nodes in one place. And here you can open it in XCode, and we'll see all results, all logs, and screenshots. Also want to mention that Sift works not only for iOS, but also for macOS test, for UI and unit test. So we have hands-on experience to use it for different projects, for iOS and for macOS as well.
As a result, those UI tests passed via Swift. Swift reported to Jenkins that they passed, and only after that, the merge pull request button is green.
Yep. And if you have any questions, you can ask.
So if I have just one node for my testing, it's not possible to implement with one node. It should be like 2, 3 nodes.
No, it's possible. It's very flexible. You can use one node, but XCode also can provide natively the parallelization within one node. But Sift is advantage of Sift that it can work not only with multiple nodes, but also it's able to rerun failing test automatically. which very useful things. So answer is yes, you can use Swift with one node, even locally on your machine.
Okay, thank you.
And it's open source, so everyone can try anytime. Here is our repo, and we have short documentation and the example of the JSON config file, how to configure the Swift. You have to specify all nodes, IP address, device ID numbers, and different paths where you want to store the test results, path to Xcode, and so on. Nothing very special, just all necessary configuration should be provided in that JSON file. And Swift support all latest Xcode, iOS and macOS versions.
Yeah, that's cool. Thank you.
You're welcome.
Any other questions? Cool. If there are no questions, feel free to reach us out if you have one, and feel free to use Swift. It's open source, it's free, and it's really powerful. The companies that are using it are big names, right? Such as Apple, and they're very, very happy about the Swift solution. So feel free to use it in your company. Reach us out if you need any help. We'll be happy to provide this help in order to set up Swift, in order to show you some particular features of it. So don't hesitate and contact us if needed.
Yeah, cool, Boris. Thank you.
Thank you.
Thank you, everyone.
Yeah, so thank you as well. Yeah. Bye, guys.
Enjoy your day. Bye.
Bye-bye.